Hey there. This video is going to introduce us to pointers, which I would argue is probably the most difficult topic in all of CSCI 1060. For that reason, we're going to devote 2 lectures, 2 videos worth of exercises to this topic, and we'll see them come up again immediately after we start talking about dynamic memory, which is the most common use case for these pointers. So, to begin, we're going to write a program with some variables, with 2 variables, one being a normal integer and one being a pointer to an integer. And we're going to use the pointer to point to our integer and use it to change its value. So I'm going to run these exercises actually using Python Tutor because what I find is that these are really, really useful to be able to see exactly what's happening. So in here, here is the exercise that we're doing. Whoa, it's way too far. Let's bring that down. Okay, so we want I to be an integer initialized to 12. We're used to doing that, that's not too hard. And now P1 is a pointer to an integer. Since it's a pointer to an integer, I need to specify that, well, what type is it pointing to? An integer. And it's a pointer, which means I need an asterisk. This asterisk can go here, doesn't really matter, but it has to be between int and the name, which in this case is P1. Now, I need to set P1 to point to I. So P1, its value is an address in memory, and I want to assign that address to be the address of I. So we use ampersand here to grab the address. Now I want to use the pointer to change the value of I from 12 to 24. So right now it's already 12. And to use my pointer and go to the value, I want to go what's at the pointer. And at asterisk is the symbol that we're going to use, which is the dereferencing operator. It means take where this arrow is pointing to and go follow the arrow to the destination. And then once you're there, now you can decide what to do. And in this case, it's make it 24. So let's watch this go through step by step. And we're going to show the memory addresses here. You can see here we've got 4 bytes set aside for our integer and 8 bytes set aside for our pointer because that's how many bytes you need to represent an address. Now, in terms of the values, I starts as 12, and P1 is going to get the address of I. So you can see here in the visualization, it's got a little arrow pointing literally to I. But the value of P1 is FFFOOOBD4, which is the address of my I variable in the computer. And now when I dereference P1, it means take this arrow, follow it to its destination, and now that I'm here, change this to 24. And there it is. For record keeping, I will make sure that this code is in Jupyter, but I'm just going to dump it here. I'm going to be doing most of the actual work in Python Tutor. So we'll make this be our program. This was example 1. Okay, and let's try the next one. All right, let's make 2 pointers of the same type and try 2 different behaviors. One where P1 equals P2 and one where star P1 equals star P2. And then see what happens if P1 and P2 are different types. So continuing from before, we can use some of this code. There we are. Okay, so I already have an integer I, which is 12. Let's make an integer j, which is 20. We'll have int p1. We'll have another int p2. And now the question is, what happens if we do p1 equals p2? Oh, we should make them point to our variables. So p1 will point to the address of I. p2 will be the address of j. And let's see what happens when we change these. You might want to predict what you think is going to happen. So 12, 20, and these are our pointers. And what does it mean to say P1 equals P2? Does it mean I'm going to change which of these 4, do you think? Well, the answer is P1 is going to move to point to the same thing that P2 is pointing to. So of these 4, it's this that's going to change, and it's going to move where it's pointing to something else. If I were to change this and use star P1 equals star P2, once again have the same 4 as before, but now instead of moving this arrow, what we do is we follow the arrow here to this 12, and we change that to 20. Now this is where it's really important to be able to see what's happening, because in both situations, P1 is pointing to 20. However, in the first example, I is still 12, and P1 just changes where it's pointing. But now in this example, where I use the dereference operator, both values are 20. And so if you were dereferencing P1 after this operation, you wouldn't see a difference because they'd be 20 in either case. But clearly the program has done two very different things depending on this. Now let's say that I change this and I make J into a double, which means P2 needs to be a double, and we'll say 20.5. Now, when I run this at 20.5, and if I try to, say, set this to what's here, it does its best attempt. So we go to what's at P1, which was I, and we assign it the value of what's at J. What's at J is 20.5. It's not an integer, so you can't put 20.5 in for an integer. But when C++ is given a floating point number and it needs to assign it to an integer, it just says, okay, we'll drop all the decimal points. So we end up with 20 here, which is fine. But if I remove these asterisks, okay, thanks. You'll see it actually doesn't work at all. In fact, you cannot convert a double pointer to an integer pointer explicitly. So because of this, only one of these two operations will work. There is no situation in which you can use a pointer to point to the wrong type of data. Even if you could, it would cause all kinds of issues because of the way that memory is being stored, especially since when you look at, for instance, these, an integer and a double don't take up the same amount of memory, so the computer would not be able to read them properly. All right, this was our exercise 2. I suppose I'll leave the one that does slightly work here over into example 2. And now we'll continue on the next one. Okay, number 3. Write a function swapnums with two pointers, which swaps the values of the integers referenced by x and y. Okay, so here is our problem. So it's called void swapnums into x into y. Now, what I want to do typically when I swap something is I want to store one of these in a temporary variable, replace it with the thing it's going to be swapped with, and then put the temporary variable back in. So let's say, for instance, I have swap 3 and 5. So x, so star x is 3 and star y is 5. Then I want temp to be equal to 3. Then I want x to become y, or sorry, star x to become star y. Because what this will do is it will replace this value with this value, which means 3 in star x becomes 5. Then I want star y to become temp. The 5 in star y becomes 3. So after working all this out, I realize the code here is actually not that long. Int temp equals x, star x equals star y, which is exactly what I wrote here, and star y equals temp. Now let's make sure it works. So we're going to first off reset these to both be integers. And now we call swapnums p1, p2. Oh, what did I make a mistake of? Oh, yes. There's an invalid conversion from an integer pointer to an integer because x is not a value, it is a pointer. I need to grab the value at the pointer. Okay, now let's see what happens. So We set up our first 4 variables just like before, and now we're going to swap them. So when I go over here, this I think is one of the most common confusions with how pointers work, is that this is not a pass by reference function. It's actually a pass by value function. And the reason for that is that you can see here, x and y are copies of p1 and p2. They are not the same. What this means is that if I were to change either of these pointers, let's say to make x point to j instead, that would not affect p1 when I leave the function. However, because x and y are pointers, when I dereference them, I'm actually accessing data outside of the function completely, which means that despite the fact that this is a pass by value function, I am able to make persistent changes to my program. And so here, temp is going to have the value 12, x is going to become y, so this 12 is going to become 20, and this 20 is going to become 12. You can see here I was doing that by accessing the addresses of I and j, which are the same values across both the main function and the swap nums function. And now when I'm finished, even though this was a pass by value function, the values I was passing were the pointers, not I and j, which means that these persistent changes actually will stick around when my function is over. But notably p1 and p2, even if I did modify x and y over here, will not be affected. Okay, so that's it for that exercise. One more to go. Or let's put this code in Jupyter for reference sake. So this is example 3. There it is. Okay, on to the last one. All right, final exercise. So here's one that has some things go wrong with it. Let's fix that text. Write a function add nums, which takes 2 pointers and a sum and combines the addition of the variables referenced by x and y with the sum. The function should return a pointer to sum, but this is going to lead to some problems. So let's see what happens when we try it out. Okay, here is my, whoops. So here's my function. We don't need swap nums anymore. Okay, and I'm going to combine the addition of the variables referenced by x and y with the sum. So that means that sum plus equals what's at x, sum plus equals what's at y, and I'm going to return the address of sum. This is a pointer to sum. Alternatively, you could write int star sum pointer it is the address of sum and return sum pointer, but this is more than you have to write because we're just going to return it right away. Now let's say that we have our int sum equals 0 and we do add nums p1 p2 sum. Let's see what happens. Okay, so the usual first 4 setup plus our sum starts at 0. We're going to, now notably, this is a pass by value function again. So the sum we're adding to is this one. Oh, actually, let's, since we're returning a pointer, let's actually assign that pointer to something. So int sum pointer is this. There we go. Just so we can actually see what's being pointed to. Okay. So our sum adds 12, then we add 20 to it, so we have 32. We're going to return a pointer. But let's think about this for a second. What are we going to be pointing to? We're going to be pointing to FFFOOOB8C. But when we leave this function, that doesn't exist anymore. So we have a problem, which is that our sum pointer is pointing to basically something that doesn't exist, which is quite an issue. So how do we fix this? Well, this is where we may want to make a pass by reference function. By making sum pass by reference, Notably, sum now actually appears the exact same way as our other pointers do. It is pointing to our sum here, but it's treated a little differently. Notice that with x and y, we still have to dereference them. However, our code is going to modify sum without dereferencing this pointer inside of our function. And the reason for that is that there's kind of two different ways that you can do referencing in C++. One of them is with pointers and the dereference operator, which is going to be necessary when we work with dynamic memory. And the other is what we learned earlier in this course, which is pass by reference functions, where we use this little ampersand to essentially make a pointer, but hide all of the, the little bits and bobs and things that you have to work on in order to actually access data. And now here, when I say return the address of sum, what I mean, I don't mean to return the address of FFFOOOB88, I mean return this. It turns out that's actually what's going to happen. FFFOOOBC4, the address of this sum, is actually put into my sum pointer, which is what I want. So it's really important to understand, and this is, I think, the most, perhaps trickiest, but most critical thing to understand about pointers, is that each pointer is treated one of two different ways. Either if you're using the asterisks to create variables to potentially pass into functions, you need to dereference them with this asterisk dereferencing operator. Alternatively, you can pass them as references to functions using the ampersand, in which case you don't use the exact same syntax, but they're treated in almost the same way. Another thing to keep in mind is it's also possible actually to pass a pointer by reference. For instance, I could pass x by reference. This won't actually have too much of an impact on what happens, but what it will do is you'll notice it actually has a x down here pointing to, you can see the little red arrow, is pointing to a pointer. And this might come up if it's the case that you actually want to modify the pointer permanently, but it's less likely to happen. However, it can be something that does matter, especially when we're dealing with memory, which we'll talk about in a future video. So that being said, I'll leave it out for now, and I will put this function into our Jupyter notebook, or Jupyter instance. Exercise number 4. And that concludes our first foray into pointers. We're going to immediately come back with another video on some more exercises to help you get more comfortable with it. So thanks for watching, and I'll see you in the next clip.